today's problem from matrix space, and the problem is let x, y be two matrix space and f, g are two functions from x to y. Okay, and it is also says that be two continuous functions. Okay, that is f and g are both continuous function from x to y. And let here a, this is x belongs to capital X, such that fx equal to gx. Okay, so a be the set of such points at which two functions are same, that is fx equal to gx, and similarly b is fx not equal to gx. Okay, then we have to given here four options and we have to choose the correct option. Okay, we first say that since a is fx equal to gx and b is fx not equal to gx, so it is clear that b, this is equal to a complement, or we write this is x minus a. Okay, since this and this are totally opposite to each other. Okay, here to solve this problem we use an important result or important theorem of matrix space, which is if maps x to y be continuous function and x0 belongs to capital X, x0 be any point on capital X, and this is if and only theorem, that is this is continuous, then f of xn tends to f of x0 for every sequence xn in x with x0 belongs to xn tends to x0. So this theorem says that if there be any point x0 belongs to x such that there exists a sequence xn in x such that xn tends to x0, then we have to prove, or then we get f of xn tends to f of x0 if f is continuous. Okay, this is the main theme of the theorem. And also we use an important result of matrix space, and it is very simple and easy result. We know that x0 be a limit point of a set A, then there must exist a sequence xn in A such that xn must be tends to x0. Okay, this is the second result we use to solve this problem. Now for the set A, we test it is open or not. Okay, to prove A is open or not, let x0, this is a limit point of A. Okay, we let x0 be a limit point of A, right? And since x0 be a limit point of A, if we can prove x0 belongs to A, then we say that A is closed set, because every limit point of closed set becomes in this set. Okay, now x0 be a limit point and we let x0 belongs to x. This is obvious because A is a subset of x. Okay, now since x0 be a limit point of A, so if we use the second result, there must be a sequence xn in x such that xn tends to x0. Okay, so there exists sequence xn, this is a subset of A, that is the sequence xn in A such that xn, this is tends to x0 as n tends to infinity. Okay, now we use the first theorem. From here, since it is given that f is continuous, we say that f of xn must be tends to f of x0. And similarly, since G is another mapping which is also continuous, so we say that G of xn, this is tends to G of x0, right? These two results we get from using the first theorem. Now since xn belongs to capital A for all n belongs to capital N, since xn be a sequence in capital A, so every point xn must be belongs to capital A. Okay, and since xn belongs to this set, so we write that f of xn, this is equal to g of xn from the property or from the definition of A, right? Now since f of xn, this is equal to g of xn, then by taking limit n tends to infinity, f of xn, this is equal to limit n tends to infinity, g of xn. Now we put the value of this limit and this limit also, so we get this is f of x0 and this is g of x0. Okay, that is at the point x equal to x0, two functional value are same, f of x0, this is equal to g of x0, and which means x equal to x0 satisfy the condition of the set A. Okay, that is we say that x0 must be belongs to A. So the limit point x0 must be belongs to A. So A is closed because A we take here x0 be any limit point of A, and we prove here x0 is in A. So A is closed. Okay, and A is closed, so our option A is closed. This may be correct. Now we look for B, and we know that since here it is already said that B is A complement, and we know that A is closed, then A complement is open. Okay, this is very simple theorem. Any complement of any set is open if A is closed. Okay, so this is B, so B is open. So our option B is open and A is closed. This is correct. Okay, very interesting problem of matrix space. And this question from, I think this is from M.Sc entrance of Benares Hindu University. Thank you for watching.